Hi, and welcome to the second section of this course, Dagger and Retrofit. In this section, we'll learn how to use Retrofit to send HTTP requests to the news web service. And here we'll also see how Kotlin can create singletons and how to get around type erasure with reified generics. Then we're going to set up Dagger 2 as our inversion of control container. And finally, we'll use Dagger to create our first use case. This is the first video of this section, Retrofit. In this video we'll learn how to set up Retrofit library and we'll talk about object keyword and reified generics. So in our Android Studio project, in the root package, add a new package called API, and inside that package add an interface called News API and add these two methods, getArticles and getSources. And you can see that both methods have retrofit get annotations and the names of the endpoints. And the names are only final paths of the URL. The base URL will be set in the API factory class that you will create after this. And you won't be implementing this interface manually. Instead, Retrofit will do it for you. And when Retrofit creates an implementation of this interface, it will search with reflection all methods that have these annotations, and then it will map these methods and store them. So when you call, for example, this getArticles method, underneath, Retrofit will send an HTTP GET request to this endpoint. And parts of the URL that represent a query are added as method parameters and have a query annotation. So in case of getArticles, we need to specify which news source we want to get and also our API key. You can also see here Kotlin default method arguments in action. So when you call this method, you only have to provide the source because API key is already here. And both methods return a generic call interface, and generic type parameter is the object that Retrofit will try to convert into from the JSON response from the web service. So in the same package, add a file named API factory, and this class will be responsible for creating Retrofit instances. And although this class is probably not needed because we'll have only one interface, we're using it to show some Kotlin features like object keyword and reified generics. So instead of using a class, we create this API factory with object keyword. Object keyword tells the Kotlin compiler to create a singleton object. When you mark a class as object, you cannot call its constructor and you can access its members as if they were static in Java by calling the type first and then method or a property, just what we need in our case, as this class is a factory and does not have a state. And the class has a generic create method, and the method has an inline modifier, and generic type T parameter has reified keyword. And when generics are marked with reified, then you can access them during runtime. And this is something that's not possible in Java due to how generics are implemented. Generics do not exist in Java bytecode, and all generic type information is erased during compile time. But in Kotlin, if you mark a method with inline, you can then apply reified to your generic type, and then you can access it during runtime. As you can see here, we're accessing this generic type T class property. And inside the method, we just set up our Retrofit client. We use OKHTTP client as our HTTP client. We add some timeouts. We add an interceptor that outputs HTTP requests to Android Logcat, and finally we create our Retrofit instance. We add the base URL, add the JSON converter to deserialize the JSON responses, and add the HTTP client, and finally we'll create a generic instance that is passed here in the method. And finally, we need some coroutines for Retrofit also, because we don't want to mess with callbacks. So in the extensions package, add Retrofit extensions file, and there add this method. Again, it is an extension method to the generic call T interface. And we already talked about this approach, converting callbacks API to coroutines in the previous section. so we're not going to go over this again. And the concept is the same. There's only one difference, and these coroutines are cancelable. So we build them with suspend cancelable coroutine, and in the continuation object we add one callback, invoke on completion, and here we check if coroutine was cancelled, and if true, we just cancel the underlying HTTP request.